Welcome to the Scaling Up H2O podcast. My name is Trace Blackmore, the host of the Scaling Up H2O podcast, a podcast where we scale up on knowledge so we don't scale up our systems. And this month, we are scaling up on Legionella Awareness. Of course, I kicked off Legionella Awareness Month, and then we heard from our friend, Dr. Janet Stout. And then we had Michael Lowenstein come talk to us, joined by Alberto Camasi. And today we are wrapping up Legionella Awareness Month. I always want to come on and say Happy Legionella Awareness Month, but I don't feel that's the right adjective. You know, for fun, I looked up different synonyms for the word happy, and I got contented, cheerful, cheery, merry, joyful, gleeful. None of those words seem to work. Fortunate, maybe fortunate Legionella Awareness Month. Advantageous Awareness Month. I don't know. Whatever the adjective is, I am just so fortunate that we have so many wonderful guests that are willing to come share information with us about something that we need to know about when it comes to industrial water treatment. And more often than not, our customers don't know what they probably should know when it comes to waterborne pathogens. And they are relying on us. And more often than not, if we do not bring that information to them, they are not asking. And if we don't bring that to them before there is an issue, that in itself is an issue. So that's why we want to make sure that we are talking about it. We are documenting that we're talking about it. And we're making sure that people have the right information to make the right decisions. When we have the right information, we are using education over fear. And nation, I have no doubt that you have seen some pretty bad water treatment decisions made because people were using fear as their motivator. That's not the Scaling Up Nation. We are using knowledge as our motivator. And we're learning ways that we can educate our customers so they can make better decisions. This interview is going to be right down that alley, so I want to get right to it. My lab partner is returning guest Loraine Huchler of Martech Systems. Loraine, welcome back to the Scaling Up H2O podcast.
Thank you. It's great to be here.
You know, you and I got to hang out in person at the latest International Water Conference. You and I saw a couple of papers together. We actually very quietly discussed a couple of papers. Well, I wonder if he's going to cover this or he should make this point. I loved listening to papers with you at my side.
That's the best part.
And as I mentioned before, you were on an earlier episode that came out in January 346. I really enjoy listening to you present papers. You're very factual. You put all the evidence out there, and you're not trying to drive people to a particular conclusion. You're just putting all the facts out of there so they can make up their own mind. I appreciate that because not everybody does that. They say, hey, this is what you need to think about this as well.
That's great. You know, my goal is to spread the word about what I've learned. I think it's not only so new, but it's so valuable. I want the profession to learn about all these things.
Loraine, if you don't mind, remind the audience about your career and all the great things that you have done throughout it.
Well, this is year 27 of being an independent consultant. I left a water treatment company after the first merger. It wasn't much fun. And I help clients manage all kinds of risks in utility water systems. And obviously, Legionella is really important in my work, but I also do equipment failure analysis. And today's topic is connecting the dots between Legionella and the loss of heat transfer efficiency in cooling water systems by the biofilm that Legionella reproduces in. The two go together. And since January, I've been investigating online biofilm sensors that provide real-time information about the biofilm that compromises your heat transfer.
Well, and that's, of course, what we're talking about today. Of all the things that I treat as an industrial water treater, I will say hands down, biofilm, the biological part of that, is by far the most difficult. They just have all the time in the world to figure out how to circumnavigate all the things that you're trying to throw at it and live and breed and all the other things that it does in the system. So I want to ask you, if somebody was just learning about this industry and we had to define biofilm for them, how would you do that?
So, in cooling water, bacteria is present because there are all these nutrients, micronutrients, airborne, as well as the concentrations of things like nitrate and phosphate. Even the treatment chemicals are nutrients. And the biofilm exists in two ways. One is free floating, but the other is what we call biofilm. It's the sessile bacteria that adheres to the water wetted surfaces in the entire system. And they excrete this slimy material, and it protects them from damage by oxidizing biocides. They're very clever, and Legionella ends up needing those higher life forms in that biofilm in order to reproduce. So, best takeaway right now is if you have biofilm, you are at risk of having Legionella. Have a space to reproduce.
Loraine, one of the coolest videos I remember seeing was a close-up of some biofilm, and they were identifying all of the different species that were in the biofilm. They pointed out an amoeba and all these other things, but then they went into how Legionella actually reproduces. So I gave you the setup in that video. How does biofilm and Legionella, how does that come together? Why is that an issue?
So think about the life cycle of any bacteria, including Legionella, which is actually an aerobic bacteria, whereas the bacteria that exist inside the biofilm, they might be anaerobic. They don't need oxygen in order to thrive, or they're facultative. They can change from oxygen loving to anaerobic. But the Legionella goes through its life cycle. It matures and it wants to reproduce, but they have to find a higher life form. It's essentially a parasite. And so it seeks a higher life form inside the biofilm. And then it reproduces. And as the juvenile Legionella bacteria mature, they leave the biofilm. But in cooling water systems, particularly in comfort cooling, where chillers operate seasonally and they're on and off, once the chiller is operating in a stagnant form, the Legionella can still reproduce in the biofilm, but then the biofilm thickness increases because you have lots more bacteria while it's idle. And then when you put the chiller back in service, the force of the water will shear off the top of the biofilm and take with it all these organisms, bacteria, and essentially inoculate your entire chiller system. It's a great mental model to think about why it's so hard to control bacteria in cooling water systems.
One of the issues we had, not just with all the chiller systems, but with the domestic water, was when all the buildings shut down during COVID. And I love Dr. Janet Stout says there was a party in your pipes and we didn't know about it. And all this bacteria was growing. All of these things were growing in there. And then as soon as occupancy came back, all that biofilm was sheared off and you had a party in your cup, I think, if you got a drink of water. So lots of things that we learned during the COVID shutdown. And we're going to be talking about not only that, but how biofilm plays a role in our efficiency. And I think that was one of the things that you really highlighted on the last episode when you were doing your experiment, that when you did get some biofouling, it was significant how much your efficiency was diminished. Can you talk a little bit about that?
Sure. So you'll see in the scientific literature statements about the thermal conductivity of biofilm as compared to calcium carbonate scale. That's kind of the benchmark. And for the same thickness of biofilm as calcium carbonate scale, the biofilm will inhibit heat transfer by 3.5 to 4 times the rate of calcium carbonate scale. We used to think calcium carbonate scale was terribly insulating, but biofilm is mostly water. And so it's extremely insulating. And you can lose heat transfer fairly quickly, and you may not even know it.
One of the things we do with biofilm is we try to add microbicides, and everything that's inside the biofilm community, they like to figure out, how do we create an immunity to this? How do we do something so we don't have to deal with the biofilm, or we can create a parachute? I don't know what I'm trying to say with that, but you know what I'm trying to say, that biofilms, they are very difficult to control. The way we control them is through our biocides, but sometimes they don't work like they should, or they don't work as long as they should. During your research, what have you learned about that, and can you share any advice?
Sure. Again, another mental model about thinking about non oxidizing biocides that are used to control anaerobic bacteria, including biofilm. We feed them intermittently. We can't feed them continuously because, for first of all, the expense, but secondly, you need to have a rather high dosage at times for different biocides. And you might close the blowdown valve and do a intermittent feed. And your understanding of the frequency and duration of your biocide dosing is rather empirical. It's an estimate. Then add the complexity that you in a comfort cooling system where you have chillers shutting down and starting up based on demand and building occupancy and the environmental conditions. It's rather difficult to precisely apply non-oxidizing biocides to consistently address sessile bacteria and biofilm.
How important is it to select oxidizers and non-oxidizing biocides?
Oh, you need both, because once you liberate biofilm from the surface, either because you have non-oxidizing biocides that started to kill the bacteria in the biofilm and they will detach from the wall, or when your chillers start up after being idle and you're shearing the top layer, you're going to put bacteria in the bulk water. So oxidizing biocide is really very important. It's a two-prong attack for bacteria.
Everybody always wants to know, how much biofilm do I have in the system? It's hard to shrink yourself down and scuba within the system. So we normally guess, but there are some devices out on the market that are being used. You've got some experience with that. Can you describe what those devices are, how they work, and how they're being used?
Sure. So there are two different technologies, electrochemical and ultrasonic. And I want to talk about the ultrasonic one because it's novel, it's proprietary. One water treatment company has developed it. And the only way that you have access to that sensor, online sensor, is to be a customer for water treatment chemicals. So consequently, I don't have the ability to test it, but what I've learned is that this is the only sensor that measures biofilm in an online system. And it has a test chamber and a heated surface and a precisely controlled water flow across the surface that matches your most vulnerable heat exchanger. And it will, by ultrasonic technology, determine the thickness of that biofilm. The question I have for people is, so if you know you have a certain thickness of biofilm, you could probably calculate the heat transfer loss in your heat exchangers. And if you're a process plant, you could calculate lost production or electrical demand in a chiller plant potentially. But if you're going to manage your biofilm, all we need to know is we have it so we can react. But there are applications where the thickness of the biofilm is very helpful, but it is more sophisticated and more complicated and more expensive and more challenging to use the ultrasonic technology than the electrochemical.
So, to make sure I understand, so this sensor sets up like a bypass environment to grow biofilm. And if that's the case, the question I have is how can you equate what's happening in that bypass to what's happening in the chiller or another heat exchanger?
That's correct. It is a model, not an in situ sensor. And that is the big drawback, is that you may be setting up an artificial environment that doesn't match your most vulnerable location. And of course, you don't have the luxury of putting a sensor in various locations to determine exactly where the biofilm might be the most prolific. But the electrochemical sensors don't require a test chamber. And so you can put them in a variety of locations and determine where you need to monitor biofilm. And you may choose a sump, which is a quiet area. The biofilm may not be mobile, and so it may actually not be sensitive to your water treatment dosing. So it's really intriguing to think about where to put these sensors in order to get early warning that biofilm is happening. There's a couple of papers that talk about the mechanism for bacteria to settle on a surface, and it's called quorum sensing, Quorum. Quorum sensing is bacteria that are hovering above the surface, and they have to kind of check it out at arm's length before they're willing to actually sit on the surface. And the second that they sit on that surface, the electrochemical device triggers a signal, and it's extremely sensitive. So these things are really interesting. I've never actually seen one in service. So I want to tell the world, this is the way that you can monitor biofilm in an economical way and in a way that you can really understand biofilm risks in your cooling water systems.
Loraine, what are some of the things that you would do differently knowing that data?
I think it's going to change the entire focus of monitoring for bacteria. I have once asked some really established consultants about who decided that 1 times 10 to the negative fourth is the right number for cooling water bacteria. And he said, well, we were in Colorado or Wyoming for the summer meeting of the Cooling Technology Institute and trying to decide what the specification limit should be for cooling water. And it was snowing out. And so we had a lot of time to think. And they came up with that number. And to this day, we have ATP. It's not a digital dip slide. We have other semi-quantitative bacteria tests like BARTs. And we talk about, using a stainless steel mesh or stainless steel coupon in the first location of the bypass corrosion coupon rack to, qualitatively see if we have biofilm. But boy, this is a big, important leap forward to have an online, real-time measurement of biofilm.
Scale Up Nation, we're going to pause this interview to hear from today's sponsor. Are you a water treatment professional dedicated to ensuring the safety and quality of your clients' water systems? Are you passionate about preventing Legionella and looking for a lab with dedicated experts ready to provide the best Legionella testing solutions? As a water treatment professional and someone who listens to the Scaling Up H2O podcast, you understand the risks associated with Legionella, the pathogen that causes Legionnaire's disease. Inconsistent testing results and delayed responses can be frustrating. Enter Q Laboratories, a trusted name in laboratory testing since 1966. With over 50 years of experience in the water treatment testing industry, Q Labs operates from a state-of-the-art 33,000 square foot laboratory recently expanded to include a brand new dedicated Legionella testing lab. Q Labs has successfully built its business by focusing on the customer first and offers a comprehensive suite of Legionella testing services to fit your timeline and budget. Whether it be the traditional culture method, rapid qPCR, or on-site mass spec identification, Q Labs has got you covered. Q Labs is a proud member of the CDC Elite Program, ISO 17025 accredited, FDA registered, and ELAP approved. Q Labs is a member of the Association of Water Technologies and is recognized by the AOAC, Microval, and AFNAR as an expert laboratory. With Q Labs, water professionals receive same-day test initiation and weekend sample receipts. Convenient, easy-to-use Legionella test kits, including shipping labels, regional courier service and drop-off, direct access to their scientists to support your Legionella testing needs. Contact Q Labs about their Legionella testing services today by visiting scalinguph2o.com/Q Labs. That's scalinguph2o.com/QLABS. By partnering with Q Labs, you will always be confident that your laboratory partner will deliver results on time while supporting your water management plans. Once again, that's scalinguph2o.com/Q Labs. Experience the Q Labs difference today. Thank you, Q Labs, for sponsoring today's episode. And it's because of sponsors like them that we're able to bring you so much content. And now, back to our interview. What's the procedure that you use with the biomesh coupons? Because I'm sure there's listeners out there today that say, I want to start measuring biofilm, but I know my customer's not going to go for this device that Lorraine's never seen in action. So I'm probably not going to get that, but I want to start somewhere. So if they can start with that, they've already got a coupon rack, they can order a biomesh screen. How do they use it properly?
Okay, well, there is a published technique on the lab method. So you install the stainless steel mesh coupon, or it might be a flat coupon. Some people have a preference in the first location before the copper coupon or a copper alloy coupon. And you do your normal corrosion coupon rack specifications for flow rate. And you have to decide the frequency in which you want to evaluate it. So maybe if you're doing monthly coupons or quarterly coupons, and you take it out and you put it in an aliquot of distilled water and you sonicate it, and it will remove the biofilm from the coupon. And then you can conduct a variety of tests. You can conduct just a culture to see what the aerobic bacteria might be. You can do the semi-quantitative BARTs for various kinds of bacteria. They even have slime BARTs. And then you can also do a laboratory culture to look at the speciation of the bacteria. So there's a lot you can do with that.
And then with that information, if you make a change on your microbicide program, you can see what the effect is.
Exactly. It is a huge help.
Do you have any firsthand experience where somebody was monitoring biofilm using the technique that you just described, and they were able to say, okay, well, this is helping us better manage our Legionella program? How do those two things correlate?
I have not seen that. I've not seen that level of sophistication in terms of measuring sessile bacteria on a mesh coupon in comfort cooling. I work both in comfort cooling and heavy industry. And heavy industry, they do not monitor for Legionella with a few exceptions. But they certainly have a lot of sessile bacteria because they have process leaks. The hydrocarbon industry, the ammonia industry, they certainly have biofilm, but I have not seen it really implemented in comfort cooling. But I've seen it implemented in process cooling, and they go to the point of culturing the biofilm because then they can select the non-oxidizing biocides that match those bacteria species.
Speaking on biofilm sensors, what types of applications are your clients using?
Well, I have 3 clients that are all in purgatory about biofilm. One client is a manufacturer of semiconductor chips. They're in the Southwest United States, and they have reclaimed water for their cooling water systems. But the stress on water volume is so strong that they have to reclaim their water after the cooling tower, and they want to figure out how to control it. The water is coming in from the chip manufacturing process. It's their wastewater, and it's got all kinds of low concentrations of exotic metals and nutrients because they use things like peracetic acid and other kinds of acid for the chip manufacture. So you have sulfates and maybe even phosphates. And so we're working with them on their reclaim system to clean up the water and to monitor biofilm in the reclaim system, the actual process. I have a beef processing plant that has to humidify the air in the manufacturing area. It's not a slaughterhouse, they're taking meat and making ground beef out of it, and it's cold, and they have a sump and they have to humidify air, and they know that they're going to get biofilm in the sump, and they don't want the biofilm to be released into the water droplets that humidify the air. So it's essentially a comfort cooling application. And then the third client is what I talked about last time, the plasma disinfection system, PDS, with the novel non-thermal plasma, copper silver ionization, and oxidizing biocide. Adding a biofilm sensor, because the whole goal is to kill Legionella, will give real-time early detection of biofilm and make precision dosing a reality for biocides.
So you brought up the plasma disinfection system. You speak at length about that and what you did on episode 346. So if anybody wants to catch up on that, by all means, go to 346. Loraine, what are some of the consequences of neglecting biofilm in water systems, specifically when we talk about the different industries out there?
Okay, so right now the focus is all about data centers. If you've watched the news, the Washington, D.C. corridor is the highest concentration of data centers. And Prince William County has just authorized a 20-year plan to build, I think it's 30 or 40 data centers. And all of those data centers have to use reclaimed water. And as more and more data centers are built, it's going to be 100% reclaimed water because it's 10% of the cost of potable water. And you don't have to expand your water treatment plant, the Municipal Water Treatment Authority. But the problem is that I don't think the engineering designers of those plants understand that the water quality actually creates biofilm. It has nutrients in it, low concentrations of chlorides, phosphates, nitrates. And so this is a real challenge. And data centers are strapped even to obtain reclaimed water. And so they want to find out how to raise the efficiency of their chiller plants. And here is an option. I want you to think about when someone designs a chiller, they put a safety margin on the heat transfer capacity. And they assume that when the unit goes into service, we'll lose, a certain percentage of heat transfer efficiency. So that's their rating. It has a safety factor. However, we're seeing that chiller plants are operating below the OEM peak design rate. And the reason is biofilm, because they can't see it, they don't know it's on the tubes, and they have no way of detecting it or controlling it. And many of these data centers have a common sump. I mean, their cooling system designs are irrational in terms of ensuring that you have flowing water at all time. They might have redundant assets because they can't shut down. So if they lose a cooling tower or a chiller, so they've got all these redundant assets that are idled, and there's no clear understanding of the idle frequency. How long should they allow a chiller to sit idle, or even a cooling tower? It's a brave new world in data centers. So I can switch over to manufacturing plants just for a minute, and they have a completely different set of operating risks. One of the issues is there's an outage every 3 to 5 to 7 years. And so the cooling system does not shut down during normal turnarounds, only during an outage. And the cooling water system is the lowest priority ever, even below boilers, unfortunately. And they may or may not want to remove the accumulated solids in the cooling tower basin. And we know that that accumulated sediment, it absorbs water treatment chemicals, especially your copper corrosion control chemicals. It is a breeding ground for bacteria, sessile bacteria. Often you'll find plants growing in the basin if it's accumulated near the surface. You can't replace the fill or this drift eliminators because the cooling towers doesn't come down. So those are the risks for biofilm and Legionella, not to mention process leaks.
What actionable steps do you want the Scaling Up Nation to take based on this episode?
I want to grow the awareness about the importance of biofilm because you can connect it to Legionella. If you have no biofilm, your risk of Legionella is very low. The second thing is to understand there are methods to measure biofilm. There's semi-quantitative, like the coupon rack with the stainless steel mesh coupon. There's real-time sensors. Now, the sensors, the electrochemical sensor that has the widest amount of application is from Alvin, Alvim, and they're in Italy, and I've been talking to them. They have applications that range from not just cooling water, but potable water, food production, bottled water, soft drink plants, processed water like white water in pulp mills, and reverse osmosis systems. Now, that one is going to be excellent because RO systems are also very challenging to manage because of bacteria.
Loraine, you sent us a great paper that I'd like to share with our audience on our show notes page so they can read up just like I did on what we're talking about here today. What are some other resources that you can give them?
The Cooling Technology Institute is a fabulous resource. They have technical papers online that you can purchase. They're creating guidelines on monitoring for bacteria and deposit control in cooling water systems. I've been participating in a document for auditing cooling water systems. These are tremendous assets. I also would welcome people who want to serve on those committees. We meet virtually every 2 or 3 weeks for an hour, and together we share ideas and actually are developing the document. So that is kind of a multi approach of both education as well as contributing to the profession. And of course, the International Water Conference, they have not only papers, but they have cooling water sessions and they have training courses at the end on the last day of the conference. It's in Las Vegas, November 3 to 7. The Cooling Technology Conference is in February in Memphis. I think it's the 2nd of February to the 6th of February. I would encourage all of your listeners to consider attending at least one. Check it out, see who's there.
Well, Loraine, we don't really celebrate Legionella Awareness Month. We bring awareness to Legionella, and I guess that's how we celebrate. But I want to ask you some specific lightning round questions as it pertains to Legionella. And one of the things I like to ask groups that I work with is SCOLE, and SCOLE stands for Success, Challenge, Opportunity, and Lessons Learned. So my first question is, over your career, what would you say your biggest success or the biggest success you've seen around Legionella?
It has to be the ANSI ASHRAE standard 188. And they've begun developing additional standards for Legionella risk management. But that one, I think, is super important. I'm struggling because people haven't adopted it as much as I had hoped, but it's a real milestone.
What would you say the biggest challenge around Legionella is?
In my world, it has to be the difficulty for owners and operators of cooling water systems to understand the risk. They don't really understand the damage it can do to their legal issues, their reputation issues, not to mention if people get sick or die. And, that's why people gamble, because it's hard to understand risk. That's a big challenge.
What about the biggest opportunity around Legionella?
Well, if you have listened to my podcast with Trace, you will know that if we have Legionella, we have biofilm. And if we have biofilm, we are losing a lot of heat transfer efficiency. And that's an opportunity to help people understand those two things happen together. And if you solve the problem by properly treating and removing the biofilm, minimize the biofilm, you will have a very low risk of Legionella. Who can argue with that? It's a lot of money you'll save in energy, water, and treatment chemicals.
And the biggest lesson learned around Legionella?
We've been struggling to test for Legionella bacteria in the water, and now we have field tests, which I talked about in episode 346. But if you have an online, real-time biofilm sensor, then you have the earliest warning possible that you're headed towards increased risk of Legionella bacteria being able to incubate in that biofilm.
Loraine, you're always helping the Scaling Up Nation learn. Thank you for once again coming on the Scaling Up H2O podcast.
Thank you so much. I love being here.
Once again, thank you, Loraine. And Loraine mentioned a couple of times episode 346. That was where she came on and she told us about the experiment that she did with the plasma disinfection system. So by all means, check that out. And that's where she got the idea for this paper, I believe, that she talked about with biofilm. And how clean is your system? And the follow-up question is, how do you know? And if you are not monitoring, if you're not testing, everything really is a guess. So we've got some techniques, some tools from today's interview that maybe you can start implementing. I am surprised how many people do not use the biomesh coupons. It's at least a data set that you can use to kind of help you gauge the system. Now, Loraine just made us aware of some very much more technologically advanced systems out there. And if you can install one of those, by all means, do that, because that's going to get you some great data. But if that's not an option for you, what is the next best option for you to get that data? And I think that's a great way to look at every single water treatment project that you are in charge of. How do I know? I'm putting corrosion inhibitor in there. How do I know that we're actually doing what we should be doing for corrosions? I'm putting microbicide in the system. How do I know what I'm doing to affect the biofilm? I'm putting scale inhibitor. How do I know that we're not scaling and we're getting proper efficiency? So all of those things, you just fill in the blank. What are you doing and how do you know it's actually working? When you start putting metrics to that, when you start putting tools to that, now not only do you know so you can make improvements, you can go to your customer and you can say, hey, look what I did. We were taking the power ratings of this chiller, the power consumption of this chiller, and look how much more efficient it is. You probably ask why that is, Mr. Customer. Well, that's because you hired myself and my team. And not only are you getting better water treatment, but you are using less electricity to operate this chiller. And these are the reasons why. And this is the data that I collected to show you why that is. Do you think you're going to be stronger in that account? Absolutely. You're going to be able to make better decisions because you've got better data. And you've got better stories with data to support it to let that customer know why you were the absolute best choice for them in water treatment. So don't guess, monitor. Loraine also mentioned that we were at the International Water Conference together. Nation, one of my favorite things to do is to listen to technical papers with somebody that can add something that wasn't said. And Loraine and I did that for each other. I wonder if he's going to talk about this. Oh, I saw this one time, and I wonder if that's an issue that he's going to talk about. And we didn't hear a couple of those things, and we heard some of those things. And then her and I would actually ask questions based on that information. Now, here's the problem. You got to be far enough back in the room that you're not disturbing people. So if your voice carries, you got to think about all that. Don't be rude to the people around you. But it really added a whole nother dynamic to listening to a lot of those papers with Loraine by my side. So hopefully she and I can sit together at the next International Water Conference. And I have to tell you, if you are not signed up for the International Water Conference, that is a great convention to go to. And they were just so awesome to me as the keynote speaker last year. I can't say enough good things about that organization. Some other organizations and some other events that you might want to look into are the Water Pro Conference. That's hosted by the Rural Water Association. That's a hard thing to say really quickly. The National Rural Water Association. That's taking place September 9th through 11th in Savannah, Georgia. We also have WEFTEC 2024. That's the 97th annual exposition and conference that they are having. That's taking place in New Orleans, Louisiana. That is a great city. And that is taking place October 7th through 9th. And then something to mark your calendars for is September 24th through 30th. The American Water Works Association invites you to celebrate Source Water Protection Week. It's a whole week to bring awareness around the impact of caring about water and making sure that we have water to last. So if you want to learn more about that and anything that I mentioned today, go to scalinguph2o.com and then over to our events page, and we will have all of that and more. Nation, this wraps up the last episode of Legionella Awareness Month. And I'm always very humbled when I see the numbers of all the downloads for Legionella Awareness Month, but then also how many people share these episodes with colleagues. These are always our most shared episodes. And I want to thank you for not keeping all that great information for yourself, but getting it out to the industry. There are only so many people that we can reach, and you are helping us grow that each and every day by you having conversations and saying, I heard this great episode. I think this will help your knowledge on fill in the blank. And we now have a new member of the Scaling Up Nation. So Nation, thank you so much for helping us grow the nation. And before I sign off, we, of course, have not heard from our friend James McDonald. So here he is with a brand new Drop by Drop.
Welcome to Drop by Drop with James, the podcast segment where we wonder, explore, think about, imagine, and learn industrial water treatment. You guessed it, drop by drop. Together. In today's episode, we're thinking about something. What are we thinking about, you ask? We're thinking about the impacts of writing "everything looks good" on your field service reports when in reality, everything doesn't look good. Does this give the recipient of your report a false sense of security? Does this help them truly manage their water systems? What about when something catastrophic happens, but your report showed everything looks good time after time after time? Does it count if you verbally told the end user the true conditions of the system but wrote everything looks good on the report to make them look good to their managers? When it comes to monetary damages and legal action, which would hold up to scrutiny? As I've always been told, if it's not documented, it didn't happen. Think about that when writing your next field service report. I'm James McDonald, and I want to encourage you to be like water by forming bonds with those around you, dissolving new knowledge, and making worthy ripples, drop by drop.
James, thank you for that. And Nation, thank you for listening. Thank you for increasing your knowledge, not only on Legionella, but all waterborne pathogens. People look up to us to provide them with information to make better decisions. And the better information that we have, the better information that we are able to give, and that allows them to make the right decisions. How many of you have a customer that refuses to make a decision because they just don't have the right information? Well, now maybe we have a little bit extra information about whatever it was you learned during Legionella Awareness Month, and that will take that account to the next level. Of course, we're going to do this next year. So if you've got somebody you want us to interview during Legionella Awareness Month, let us know who that is. Of course, if you ever have any ideas about a show, you can go to scalinguph2o.com, go over to our show ideas page, and let us know whatever your idea is. We use that to make sure we always have great content to bring to you each and every week, like we did today and like we're going to do next Friday. Until then, have a great week, folks.